My name's Phil Kithil. I'm with Atmocean Inc. It's a company I founded in 2005, and the original idea was to use wave action to generate upwelling of deep water. Deep water has both more nutrients and is colder than the surface water typically. And so this is our 24th actual ocean test of our different applications of our technology. We've looked at the effects of upwelling cold water in large quantity to reduce hurricane intensity. And in fact is possible, and that's relevant today, the 30th of August, being an anniversary of Katrina hitting New Orleans. Back in 2005, that's what prompted the idea. We've also looked at the benefits of upwelling nutrients. The deep ocean has more nutrients, upwelling nutrients to increase phytoplankton to help regenerate the ocean food chain. That also is a way to, in a very modest manner, counteract the climate change by enhancing naturally the ocean's uptake of CO2. Phytoplankton absorb CO2 when they metabolize the nutrients. So if you can bring up the nutrients, you get more biological activity. And phytoplankton are the base of the food chain, so that also has benefits to the entire ocean fishing resource. And we, in about 2009, began to take a look at the wave energy application of our system, made a few modifications to it, and have come up with a rather unique system. It's based on hydraulics, so we generate pressurized seawater, and we bring that on shore in a high pressure line, operating at 200 to 300 pounds per square inch PSI. And then we feed that pressurized seawater into what's called a Pelton motor. It's basically a high-tech water wheel, and that gives you torque and RPM on a drive shaft. You can take that directly into a generator and you can generate electricity. So our system's a little different, as I mentioned, from many of the others that are in the wave energy field. Many of them generate electricity in the ocean, and then to bring that back on shore they use electrical cable. That's fairly expensive, especially in a higher throughput or higher capacity. I've been told $1 million a mile, for instance. Whereas the hydraulic hose that we use is something like $50,000 a mile. So we're 20 times cheaper on the transmission side of it, getting the energy on shore, than the electrical generate electricity in the ocean approach. The system is basically three different components leaning against one of our buoys, and these are designed about 10 feet diameter at the top, and they're designed to actually fit on their edge in standard 40-foot containers. So our market is, at least initially, islands that are currently burning diesel to generate electricity. And with the ease of transport of our system, we can manufacture in quantity and ship them in quite easily to these islands and remote coastal regions also. And so we've taken a market-first approach to the design and application of the technology. What is the low-hanging fruit, if you will, for wave energy, and it's places that are paying 30 cents, 40 cents, 50 cents